Now let me show you how to solve for stair values using the advanced stair function. Let me start off by pressing convert to times to clear everything out to a good starting point. Now to get to any of the advanced functions, you can see the advanced label across the top here, you need to hit the convert key. It's a second function of stair. And as mentioned in the introduction, we can proceed through this calculation by multiple presses of the stair key, or by using the up and down arrows, or by using the enter key. In this example, we'll use the enter key. It's prompting for a floor-to-floor rise. Let's give it a 110-inch floor-to-floor rise. It's asking for a target riser height. 7.5 is a good target. We'll leave that. That's the default value. The stair run, we're going to say there's no horizontal constraint, no run needed for this one. The target tread width of 10 inches is fine. The top floor thickness default is 10 inches. That's good. And the headroom, 80 inches, is good as well. The upper flooring thickness, we're going to say we have 3/4 of an inch thick flooring at the top. And the lower flooring thickness, we're going to go with a 1/2 inch thickness on the bottom. The nosing length, that's the amount of overhang of the tread over the top of the riser. So we're going to go with a 3/4 inch. And the riser thickness can also be 3/4 of an inch. Now it gives me my net floor-to-floor rise of 110.25 because of the difference between the upper and lower flooring thicknesses. The number of risers is going to be 15. The actual riser height is 7 3/8. The number of treads is 14. The tread width is the target 10 inch. The minimum stairwell opening, 125. The stringer length. The incline angle. The rough stair run, 140 inches. And the finished stair run, 141.5. The toe position, this is starting at either the top or the bottom of the stringer, is the position of the first tread along that stringer. So the first position is at 12 7/16. The second one is at 24, and so forth, all the way down the stringer. This is a position of each tread that you can mark and cut till you get to the very last one right there. So now let's say you have a situation where you do have a horizontal run constraint, that 140 inches brought it down to right to the edge of a door at the bottom, a closet door, and you want to back it up from that, say 3 inches. So we can edit this whole calculation by using the arrow keys, and let's enter a stair run of, say, 136 inches. Enter that in, and rather than go through all the variables again, we can use the quick solve function, which is a second function above enter. We hit convert, enter, takes us directly to the net floor rise, number of risers, the actual riser height, number of treads. And now you see here, the little alert symbol says our tread width is now 9 11/16. So it's a little bit shorter than our target. That's because we had to back up the whole stairway and make everything a little bit shorter. But it's fine, it's still workable, so we'll keep going. The minimum stairwell opening, stringer length, incline angle, the rough stair run, and the finished stair run is now within that space, so we no longer conflict with the door or the object down at the bottom of the stairs. The toe positions have all been changed and adjusted all the way through to the end. And that's it. It's just that easy. So that's a quick overview on how to use the advanced stair function. For more details, you can download our user guide at www.calculated.com/support.